My name is Neha Pasricha, and the public lecture I attended was The Physics of Genes and the Promise of Personalized Medicine by alexsei. The lecture began with a quick summary/review of DNA helix structure and its properties. For example, Alexei described how DNA is a highly negatively charged polymer which is attracted to itself because of elements such as salt, sodium, magnesium, or calcium in the surroundings, which induces the attraction. Alexei further explained that DNA is not the sole source of all genetic information and its expression. Epigenetics and methylation play a large role as well. Recently-ish, the Human Genome Project identified all 3 billion plus genes on DNA. In fact, people have now turned to sequencing all the proteins in the human body, which could potentially be more difficult. Being able to use this information to distinguish differences in DNA code could prevent cancer and help in single-cell sequencing and prenatal diagnostics. I learned that many companies, including Oxford Nanopore Technologies, are working towards making DNA sequencing accessible to the public by continuously searching for a more efficient and cheaper way to sequence and read DNA. Currently, the Minion, a DNA sequencing tool, has an 80 to 98% accuracy rate and provides a direct readout of epigenetic markers. This tool could be extremely effective in diagnosing people with life-threatening diseases early enough for doctors to cure them, potentially. The speaker, alksimentiev, ended his lecture with an intro to DNA origami and how DNA can be used to effectively deliver drugs to target cells, potentially help cure diseases, etc. This topic was of interest to me because for a long time I wanted to be a geneticist and help cure cancer, but that was before I realized how hard chemistry was, and I didn't want to take it. The entire lecture was extremely helpful in teaching me a lot about DNA itself and how DNA markers and epigenetics, as well as the physics behind the tools in DNA sequencing, can be used to potentially cure life-threatening diseases, and I found that extremely fascinating.